Hiya, it's Goblin Henchman here. So I thought I'd do a quick video of this idea I recently posted about a Caterpillar game engine. More specifically, focusing on this article I wrote here, which was Caterpillar method for character stat generation. So the idea is that you roll 3d6 like this, and then you put them in a sort of caterpillar-like shape in a kind of in a row with the faces touching, and then by using certain rules you can generate a character. Now I generated two sets of rules. The first set of rules mimicked a 3d6 bell curve over the long haul, and another set of rules I generated mimicked the 4d6 like method over the long haul. So these are averaged over like 10,000 rolls. It's a bit of a brute force. There's some approximations that are a bit a bit crude, but generally the characters on average are within those sort of bands. So when I generated this, first of all, it was a bit of a kind of bit of fun. But the more I looked into it, actually, the more actually I think it became interesting because it had these sort of lumpy bits. Now, on average, they mimic 4d6, drop the lowest, or 3d6. But but individually, it could be lumpy because what you do is you get a high stat in this range, a low stat in this range, a medium stat in this range, and then three standard bell curves, although they're not quite standard, and I'll get into that. So I'm just going to go through an example. So imagine we've rolled 3d6 and we've arranged it in a caterpillar. Now these have been staggered so you can see all the faces because I want to show you the maths. So in the head rule, you add up the exposed faces. So this is going to be the head die. So it's a 1, and the opposite face will be a 6 because they always add up to 7. But 7 plus 3 is 10, and opposite a 2 is a 5, so that gives you a 15. For the thorax, you just add up the exposed faces. So again, opposite faces is 7, plus 1 is 8. And for the tail, using the 3d6 method, you add up these three faces. So opposite faces again are 7. 7 plus 3 is 10, and 10, and then it's minus 2 this time. Unlike the head, it was add, the tail is subtract, so you get an 8. Now, if you wanted the 4d6 drop the lowest method, you'd basically treat it as two head rolls, if you like, not a head and a tail. And so in that case, you get a 12. But let's move on. Then you add up the front faces. So a 1 plus a 2 plus a 1. That gives you 4. Now this is where it becomes interesting because these are counterbalanced. Because as I said, opposite faces of a d6 add up to 7. So as the front face goes low, the rear face will go high. So this is a 4, but this will be a 17, 6 plus a 6 plus a 5. Then finally you add up the top, which is 3 plus 3 is 6 plus 1 is 7. So there you go. You get a character that had a 17, a 15, an 8, a 4, and a 7. And if you're playing the 3d6 rules, you get another 8. But if you're playing the 4d6 drop the lowest, you get a 12. So here you go. So the 15 falls in here, corresponding to the high range. The thorax is here, corresponding to the middle range. The tail would be an 8, which is actually quite high on the tail end. The front is a traditional bell curve, but because they counterbalance the other one, so you're getting a 4 here, but a 17 here, see? And then finally, the top is actually independent of the front and rear, well, more or less. So I think actually it does offer this sort of quite an interesting, unique system for rolling, but also having a degree of balance in it, because you're always going to get a high, a low, if you're using the 3d6 method, or two highs, if you're using the 4d6 drop the lowest, a medium, and then this bell curve. But again, one bell curve is sort of independent, but the other two are counterbalanced. So you'll get a 3 and 18, or a 4 and 17, or a 5 and 16. Obviously, if you get a 10, you'll get an 11. So in the middle, they're sort of more even. So if you're looking for something different and something that isn't crazy, it's not going to break the system, but it's going to give you a character with at least one good stat, then you could give this a try. Just to show you, did I show you these bell curves? Here we go. This is where I model the system against the standard ranges. Anyway, give it a try. Thanks. Bye.